Okay, today's topic is force on moving charge in magnetic field from current electricity electromagnetism. Oersted first discovered magnetic effect of flow of current in any conductor. He supposed when electric current was passed through the conductor, then magnetic field is produced around the it. So, force on a moving charge in magnetic field. When charge is placed around the magnetic field B, a kind of force is produced, and produced force is called Lorentz force. So, here we want to derive the relation between the force and charge moving with velocity v and magnetic field B and angle of inclination between V and B. For the derivation of this force, produced force, here is figure. For the description of this figure, here in this figure, magnetic field is parallel. B is parallel with this produced field, and charge is placed around this magnetic field, and the charge is moving with velocity v, and theta is the angle of inclination between moving velocity v and magnetic field b, which is shown in figure. So this is given here. Suppose a charge q is moving with velocity v inside a magnetic field b. It is found that the charge experiences a force F such that the force is directly proportional to first the magnitude of the charge q. Symbolically, F is directly proportional with q. This equation first. Second, the speed v with which the charge is moving, that is, F is directly proportional with v. This equation second. And the applied magnetic field B, that is, force is directly proportional with B. B means magnetic field. This equation third. And finally, the sign of the angle between direction of V and B, symbolically F is directly proportional with sign of the angle between V and B, that is sine theta. This is equation 4. Now, by combining these above relations, we get F is directly proportional with BQB sine theta. After this, F is equal to K BQB sine theta, where K is a proportional constant. Experimentally, it is found that when K is equal to 1, then above relation, this relation becomes F is equal to BQB sine theta. When K is equal to 1, K is removed. Then F is equal to BQB sine theta. This is equation 5. So when we write equation 5 in vector form, we can write F is vector F is equal to Q vector B cross vector V. Simply this equation can be written. We know that A cross B is equal to AB sine theta. So BB sine theta, in spite of BB sine theta, we can write B cross B. This is equation 6. So here is some special cases which are obtained from equation 5. So first case is when theta is equal to 0 or 180 degree, then equation 5 become F is equal to BQB sine 0 degree or sine 90 degree. Sine 0 degree or sine 180 degree means its value is 0, so it is minimum. Force produced at that case is minimum. Second case, when theta is equal to 90 degree, then F is equal to BQB sine 90 degree. We know the value of sine 90 degree is 1, so force is BQB. At that case, produced force is maximum. Third case is when V is equal to 0, that is, there is no any velocity or speed of the charged particle. At that case, F is equal to 0, means there is no any force is experienced. And last case and final case is when Q is equal to 0. It means when there is no any charge around the magnetic field, at that case also force is equal to 0. So today's video for force on moving charge in a magnetic field. So this force is the relation between the force and BQB sine theta is equation 5. So this is the beautiful result. We can apply this result in number of various forms, in various derivations, as well as to solve numericals. Thank you for watching this video. Thank you so much.